Okay. Page 90, 2-6. Solve addition and subtraction equations. Okay. Now, as we talked about on Friday, we were always thinking about doing the opposite to isolate the variable. For example, what is it that I need to find for this particular equation? I need to find out what equals. I need to find out what, Sarah? What x equals, right? I just need to know what x equals. So in order for me to do that, if I can get my equation to say x equals whatever I find will be the solution for the equation. So I look at the side of the equal sign that has the variable, and it's an x plus a 4, and I need to do the opposite or inverse operation, and I need to do it to both sides. So the opposite of adding 4 is going to be what, Calvin? Subtracting 4. And if I do it to one side, I need to also do it to the other, and the solution should be 34. How do I know if 34 is the solution? How am I sure? Yes. Plug it back in. If I'm thinking it equals 34, 34 plus 4, does it equal 38? If so, then yes. Okay? So that's kind of what's a little perplexing about the assignment you had for today with the estimation. Even if you were maybe not totally understanding things, if you would have plugged in some of your solutions that you had, you would have seen that you were way off and maybe had to make some kind of an adjustment. I mean, that's the great thing about equations, is that if you are willing to take the extra time, really not that bad. So let's just dive right in. Take some examples. And since the title of the lesson is Solve Addition and Subtraction Equations, you are going to be doing which of two operations? Adding or subtracting to find your solutions. So no multiplication or division today. That'll come tomorrow. But some may argue that the adding and subtracting is sometimes more difficult. So here we go. N minus 53 is equal to 28. Try that one. And then try x plus 46 is equal to 72. Okay, n minus 53. What's happening to on the same side of the equal sign as n, Brandon? Right now what's happening? We are subtracting. So the opposite is subtracting 53. Adding what? To where? And both sides, right? And 28 plus 53, Brandon, is 81. How do you know for sure? Plug it in. Okay. Next one, x plus 46. The opposite of adding 46 is going to be subtracting 46. X now equals 26. And how are you sure? Plug them in. Okay. Any questions? Have you got them both? Maybe plug them in. Are you supposed to? Well, that's the question, right? What happens if you don't plug them in? Get them wrong. So I don't know. How important is it to you? 2 days from midterms. Does it really take that much longer to plug it in? Sometimes it's just the visual. Sometimes it's just like if we go back and say, well, if I were to think, well, what if I had something like What if I said the answer was 25 for this first one? Because I decided to take 53 minus 28. I went the completely wrong way. And if I were to plug that in and say 25 minus 53 is 28, something should go off and say, you know what, I think I made some kind of mistake. Logically, it just doesn't make sense. Okay, give it a shot. We need to remember when you are adding or subtracting with decimals, you must line up the decimals. So, Maddie, you can help me. You volunteered. You did. You didn't even know it. Now, you did. You did. X minus 5.7. What's happening here on the same side of x? You are subtracting how much? What are you subtracting? Good. So the opposite of subtracting 5.7 is to do what? Add how much? 5.7. So when I add 5.7 to that side, takes away the negative 5.7. Add 5.7 to this side by lining up the decimals. The reason why we line up the decimals is so we can just drop it right down when we have 7 plus 7, 14, and then 6 plus 5 is 11. Your solution, 11.4. What's negative? Yeah, well, you know, essentially, Joe, that's what it is. I mean, we're so conditioned to looking at it as a minus 5.7. But really, you know, it can also be looked at as a negative 5.7. Just like the x can be looked at as a positive x. It's just how you want to look at things. And once you get further into, like, the algebra stuff, then it'll force you to do that because we'll be switching stuff around, moving things. Okay? Another one? Of course. Think it through. Follow procedure. Anything about the way this one is written that threw you off a little bit? Or maybe it didn't throw you off, but you could see how it might throw someone else off. Sarah?
The equal sign before like an equation, you could just like switch.
Yeah, we're not used to seeing basically what we call our answer first, then equals, and then the problem. Usually it's the problem equals the answer, right? What can I do anything to that to make it look more familiar? Trinity. How? Without changing the problem, how can we rewrite it? Right? Now, if you look at these kind of like shopping bags, and you just kind of pick them up and then just move them. As long as the order stays the same. Do we still have n minus 0.35 like we had here? Sure we did. We didn't change it and say, we didn't flip it around like, oh, now we're going to take 0.35 and we're going to subtract n. No, we kept it the way it was. So now it's quite easy to see what the opposite has to be. If I'm subtracting 35 hundredths, the opposite will be to add 35 hundredths. And I better make sure to do what? Line up the decimals, right? So just add a 0 there just to tidy things up. 5, 11, 6, n should equal 6 and 15 hundredths. Now again, you want to just double check, plug it in. Does that should make some kind of logical sense to you? Okay. Any questions so far on the basics? Flip your worksheet over 2-6. And I want you to specifically look at number 4. Got 4, 8, 12, 16, 20, that whole column. They're all written the same way, and they're all just slightly different than what we've been talking about. Okay? So just bear with me here for a second. I know some of you are like rabid dogs when you get the homework in front of you. You can't help yourself. You just want to get started. You want to see this. What is different so far about the way this one is written? How is this one just slightly different than all the other ones that are on that in that section 1 through 20? Trinity. Yeah, the A is on the inside. Is it as easy for me, like if this, just don't write this. If this were addition, what simple thing could I do to make it look more familiar to me? Yes, Elliot. I could switch what around? A plus 10? Why can't I do that the way it's written now? Why can't I do that? Can I switch the order when I subtract?
No.
No, I can't switch the order when I subtract. So what do I do? Here is what I have to work with. What do you want to move? Do you want to move the 10 or do you want to move the negative A? Either way will work. You decide. I want to try to get A by itself, right? Just like in all the other problems, I try to get the variable by itself. So sometimes that means I got to do a little house cleaning. What do you want to do? Get rid of the 10 or get rid of the negative A? What do you want to move? You want to move the 10? What kind of a 10 is this? How do you know it's positive? There isn't what in front of it. Right. So if this is a positive 10, how am I going to get rid of it on this side? What's the opposite? How do I get rid of positive 10? How do I get rid of $10? Right. Take it away. So if I take away 10, I need to also take away 10 from this side. That's going to be more difficult. Why? Because it's going to give us what? 3.4 minus 10, I'm going to end up with negative. Let's rethink. Not impossible, but I don't know if you're quite ready for that. Let's get rid of the A. We're subtracting A. What's the opposite of subtracting A? Let's add A. When I add A, it's gone from this side. Let's add it there. Now, essentially, what we have is what? 10 is equal to 3.4 plus A. Can I switch things around, make it a little bit easier, a little more pleasing to the eye? Sarah? 3.4 plus A equals 10. Can I make it even more pleasing to the eye? Can I make it even more pleasing to the eye? Can I switch the order now? Yes, because I'm adding. So let's do that. Let's switch the order. Now it should be a slam dunk. A plus 3.4. Now what? Now it's like all the other ones we've talked about. The opposite is to do what? Subtract what? Subtract 3.4 from both sides. When I subtract, I'll need to bring that 0 up. And we should end up with equals 6.6. Plug it in. The original problem.
Is that the only one that does that?
No, all the ones in that column are like that.
Oh,
Essentially, what did we do? I mean, what did we end up doing? We took the 10 and we subtracted what? So the shortcut there, once you know what you're doing, for number 8, what am I going to subtract for number 8? I'm going to say 14.3 minus 6.3. That will give me my solution. For 12, 3.9 minus 3.1. 16, 18.4 minus 9.6. And 20, 8.3 minus 2.7. All that stuff on the board is the explanation as to why you can do it. It's justification. Okay? So if you were listening, maybe you just jot that down next to those problems and you know exactly what you have to do. If you weren't listening, revisit the blog. I just told you exactly how to do 8, 12, 16, and 20, how to set them up. Okay? So 1 through 20. Yes?